DFMA is a methodology for optimizing a new concept or an existing design with respect to manufacture and assembly by reducing the number of components or processes needed. By eliminating excess components, we also eliminate the drawings of these components, the need to keep them up to date, the risk of wrong production of the components, the need to store them, as well as the risk of incorrect assembly of the product itself. The cheapest component is one that does not exist. The DFMA process consists of 4 steps: conceptualization, analysis, redesign, and conclusion. To understand each of these steps, we are going to apply the DFMA process to a simple everyday product, a tea set, which includes a teacup with an ear, a saucer, and a spoon. The teacup, its ear and saucer are made from ceramic, while the spoon is made from stainless steel. During the conceptualization phase, we review the user requirements of the product. So what are the user requirements of a domestic tea set? Well, from a functional standpoint, it needs to be able to hold a hot liquid. It should be possible to pick it up easily with one hand without getting burnt, and to place it on a flat surface like a table whenever needed. It should include a mechanism for stirring the liquid, and it should protect other surfaces from spillage. And finally, from a commercial standpoint, it should be affordable and attractive to the target market. During analysis, we assemble the product piece by piece on paper to build an assembly diagram. An assembly diagram consists of 5 different types of objects: components, processes, combined components, the main assembly, and sub-assemblies. The goal of analysis is to uncover at this early stage any excess components or processes which may exist. A component is made up of a single piece and is supplied as is for assembly. In our tea set, components include the spoon, the ear, the cup, and the saucer. Individual components in the assembly diagram are evaluated by means of 3 elimination questions. The answers to these questions help determine whether the component can be eliminated without the loss of functionality through integration with other components. Components that could lose their right to exist in their current form are referred to as suspect components. A process is an action done on a combination of components during assembly. The application of glue to attach the ear to the cup is a process. If the component requires a protective layer like a coating, then the application of the coating is also a process. If the coating is on a component you buy, like a galvanized bolt, it's not seen as being separate, and the 2 are considered to be one component. Processes are also evaluated using the elimination questions, and those that could be eliminated are marked as suspect processes. A combined component consists of several components, but is delivered as a combination and cannot be easily dismantled. A ball bearing or photocell is a combined component. A main assembly is the product for which the assembly diagram is made. It consists of components, combined components, and sub-assemblies. In our case, this would include the saucer, the cup with its ear, and the spoon. A sub-assembly is a combination of 2 or more components, treatments, or processes which must first be assembled before they can be incorporated into the main assembly or another sub-assembly. In our example, the cup and its ear together form a sub-assembly. Let's now look at the 3 elimination questions to find suspect components and suspect processes. The first question is, should the component move or be able to move in relation to the preceding component in the assembly diagram? Look at the cup's ear. Does the ear need to move in order for it to function? The answer is no, and in fact, it doesn't move because it is glued to the cup. Then we ask, are there fundamental reasons for the component being made of a different material which does not otherwise occur in the product? Once again, let's look at the ear. The ear does not need to be of a material different than the cup. It too is made of ceramic, so the answer is no. The final elimination question is this: should the component be fitted or removed separately, because otherwise assembly or disassembly of other theoretically essential components would be impossible? So in our example, we ask, does the ear need to be detachable in order to execute any of the processes associated with the product, like drinking or cleaning? The answer is once again no. If the answer to each of the 3 elimination questions is no, then the component, in this case the ear, becomes a suspect component and a candidate for integration with another component. Consequently, the process of gluing the ear to the cup also becomes a suspect process. If during the analysis phase, components or processes are marked as suspect, then a redesign can be considered. In our example, we marked the ear as a suspect component and the gluing of the ear to the cup as a suspect process. So now we ask ourselves, is there any way we could eliminate these suspects while retaining the functionality of the product and perhaps even improving it? We can make the ear an integral part of the design and production of the cup, so that the cup and ear are a single piece of ceramic. This will eliminate the ear as a separate component and eliminate the process of gluing of the ear to the cup. Once the redesign is done, the results are incorporated into a new target assembly diagram. This final step of the DFMA process primarily involves the creation of a report in which we capture key information like details of the participants in the DFMA process, date and location it was held, key user requirements, outcome of the analysis including assembly diagrams, description of alternative designs, and finally the evaluation of key issues and action points. It is at the conclusion of the DFMA process that real work begins, where ideas and actions make their way into the real product, and when the results of the effort start to become apparent.